Hello folks. Okay, this time I want to get into talking about refactoring. So if you've got a big chunk of software out there that you're having to maintain over a long period of time, as we talked about in the maintenance section, gradually it's likely to get less and less suitable for what you need right now. Either it's starting to become slow compared to what you want or compared to what else is out there, or it's getting costly, difficult to support, difficult to maintain, or there's new problems that it just can't seem to address. So when you get to that point, you've got a few possible choices. You can go out and build a new element from scratch, which can be pretty costly, and it's risky, right? You've got to put the time into designing it and developing it, and you're never sure it's going to work until you actually get it. Or you can go out and purchase something off the shelf, purchase something existing and try and customize it. And that might work well, but it might be more than you need or might be less than you need. So that you might be paying for more than what you need, or you might be only using, or you might have to build a bunch more onto it anyways. So one of the things that's often considered is, well, can I take my existing code base and just replace a chunk of it? Is there one chunk or a couple of chunks that are the root of the problem for us right now? Can I take that out and rebuild that piece and keep the rest of it in place? So again, a variety of different ways that we can approach that. We'll take a look at a couple of them. This is going to be a lot easier, obviously, if we've followed a good modular design, lots of abstraction, loose coupling, right? So that we can actually pull one piece out and replace it relatively easily. So a few different ideas. Maybe all we need is a little bit of extra functionality. There's something that we can't do right now with the system, but we need. So hopefully, assuming that we actually have the rights to the code, right? Assuming it's actually our code or we've purchased the rights to it so we can go in and modify it, and we've got the expertise to do that, then hopefully we can just identify which component needs the new functionality, build our new functionality, and embed it there. And again, if we've got a modular design, hopefully this is relatively easy to do. Again, it depends on just the nature of the new functionality and how well that fits with the modular design that we had, let's say, but hopefully that's a feasible approach. Another problem might be that it's performance that's an issue, where the system is becoming too slow or it's using too much memory or whatever it might be. It's just not performing well enough anymore. So in a case like that, we have to identify where the bottlenecks are, what part of the system is actually causing the performance problem, and see what kind of new target we'd like to hit. Is it 50% too slow? Is it 100% too slow? What is just how much do we need to speed up? Not just how much do we need to speed up for right this moment, but how much do we need to speed it up or improve the performance so that it's still going to be effective, a year down the road or 5 years down the road or whatever our timeline happens to be. So we use profiling to figure out where the problems are, and we try and figure out what kind of an improvement we need. How much do we need to improve that performance? So again, maybe we can go through and simply pull out the relevant components and replace them. That would be the ideal. If we've got a good modular design, maybe that's possible. Maybe we can pull that piece out, come up with a new and improved version of that piece, and then replace it. Sometimes we can go through and say, well, maybe I don't have to actually rewrite that component. Maybe I can do something to the data beforehand so that that component works more effectively. So if you're dealing with data, maybe if I do something to sort the data beforehand and then give it to the component will run much faster. Again, maybe there are things we can do pre-processing or post-processing to try and improve how it's going to behave. Right? So these are all possibilities we can consider. So is there a piece I can plug in before the component that will give us the performance boost that we need? Or again, can I simply pull that component out, rewrite it, and replace it? Maybe the problem is that the data that we need has changed substantially. So as time goes on, the way we get our data from other systems might change completely, or the kind of data that we have to process might change quite a bit. The format it comes in, or the format that we have to send it out in. I mean, data formats are changing all the time. Maybe we have to adapt our new system, and right now it's not suitable to work with whatever new data format we have to deal with. So in a case like this, again, maybe we pull a component out and rewrite it to work with the new data format. Or maybe we go through and say, well, what if we just built kind of a translator, something that would sit between our system and whatever it's interacting with, so that this translator, if you like, took the data that's coming in from the outside world, translated it into a format that our system can deal with, and then piped it into our system. So the system doesn't have to change, but we get the effect that we want. And again, the same thing going in the other direction. Our system spews out the data in format X, and our translator rewrites that into the new format that we actually need it to come out in. So maybe, again, we can essentially build an interface or a wrapper around the component that no longer meets our needs, so that we get this translation taking place. Right? Just something in between to take care of things for us. Now, there are times when the software is stuff that we don't actually have the rights to, or we don't have the source code for, or it's just so old that we actually don't have the tools to update it anymore, or we don't have the expertise to update it anymore. So sometimes there is a chunk of software that we have that doesn't meet our needs anymore, but that we can't get at the guts of it. So we could go through and try and develop a replacement from scratch. But again, that's costly and risky, especially if this is really old software. We might not know all the different weird things it's doing internally to get the effects that it's getting. So it can be risky to try and guess that we can simply rewrite it. So this is another one of those places where we quite often come up with some kind of a wrapper where we have our legacy piece of software on the inside, and we develop something around it to add any functionality we need, communicating. So our wrapper, if you like, this layer in between, will communicate with the legacy system and with the outside world and translate between the two of them. Again, same sort of ideas we were looking at in the previous example, where what we've got is an old system we're trying to hang on to that doesn't entirely meet our needs or can't entirely communicate with the outside world anymore in the way we need it to. So we come up with something that can translate between it and the world at large and do the extra functionality that's needed. And so there are all sorts of possible ways we can deal with the issues that we face. Again, it's often going to be a mix of these problems. By the time you get to the point where a client actually goes, this thing is junk, I need something better, there's often a variety of different problems mixed in there. There's going to be some performance issues and some compatibility issues and some legacy issues, and you're going to need to go through and analyze those problems, prioritize them, look at what the customer needs, and look at what they've got and what their tolerance for risk is, what kind of a time frame they're talking about, what kind of a cash flow they're talking about for this, what kind of expense they're talking about, and try and come up with some kind of a balanced solution that looks at the kind of the best mix of solutions, if you like, to solve all or to solve enough of their problems to make them happy. So what you're often going to find yourself doing is coming up with a few different approaches. Say, okay, well, you can go through and entirely replace the thing, build new from scratch, and give them an idea of what that's going to cost and what the risk associated with that is and what the benefits are. Or you could go through and here are these other products out there that we could buy off the shelf and then tweak so that they do what you want. And then you could go through the cost benefit analysis for each of those, the pros and the cons for each of those. Or you could go through and say, okay, well, or you could take this kind of an approach where we try and refactor individual pieces of your current system. And here's the advantages, here's the disadvantages. Right? So often you're going to go through and come up with a variety of different possible solutions, outline them to the client, outline the risks, outline the costs and benefits, and let them come to an informed decision about which approach they want to take, and then follow that through. All right, well, we will leave that one for there.